Welcome to China Manufacturing Decoded from Sofeast, the podcast where we take you through some of the major topics facing importers and manufacturers in China today.
Hi everybody, you are listening to episode 61 of the pod. It's Adrian here and I'm joined by our CEO, Renaud. Hi Renaud.
Hey, hi Adrian, hi everybody.
So today the topic is managing tooling in China and also covering what a tooling contract needs to include for importers. And so we're really going to get into what this management means and a lot of the risks that you're trying to avoid that can cause you trouble when you're fabricating your tooling in China or maybe other Asian countries, and also managing it once it's in use, storing it, and all of the rest of it. So really, it's over to you on that, Renaud. So I guess the first thing to start off with is, when we talk about managing tooling, I mean, what is included in that?
Basically, let's say you are a buyer and you're developing your own new product. Okay, a product that is not currently made by the factory. So the factory needs some tooling to make it, right? Tooling, let's take plastic injection molding because it's the most common, extremely common in China. So let's say you have some kind of electromechanical product, some kind of maybe home appliance or another type of product, and you want maybe the enclosure to have a different look. And maybe there's also some internal parts that need to be made to your custom design. Okay, so if you want to make it in volume, you're going to go for the plastic injection molding process. Okay, and you cannot do it without tooling, without the molds actually, where you inject the thermoplastic and it solidifies and it's ejected and you use that part once it's cooled down as a component of your product. So let's take that as a definition of tooling. As a buyer, where is the tooling going to be made? It's going to be made either by your plastic part supplier or by a specialized tooling fabrication shop that usually they subcontract to. So managing tooling really, it depends. If you are very hands-off and you cannot trust your supplier, then you just tell your supplier, well, okay, I need this. Let's say you buy a mouse, okay, for your computer. I have one right here, so you can think of that. You're going to buy a mouse with your own design, and you find a supplier, and you tell them I want this design. They say, okay, there's going to be a mold to make. Okay, fine. So if you're very hands-off, so they might say, okay, we believe in your product. You don't pay anything for the mold, and we'll just charge you for the, to get our money back, a little bit more per unit cost. And some customers are very happy with that because it means lower investment. Some customers reject that because it means, lower control. It means usually they cannot own the intellectual property. And very often the mold itself is, its shape, its design is a big part of the intellectual property rights of the product, right? So a lot of customers, especially when they've done a few rodeos, they don't like that. And they say, no, I want control. I'm going to pay. Okay, so in either way, even if they pay, but they're very hands-off, well, they let their supplier arrange everything, right? And in that case, managing the tooling is just sort of managing the expectations before. So that means, is it going to be made in hard steel? What grade of steel? How many shots can we get? And one shot is one piece, okay, then I understand. Do we own the intellectual property rights? Can we write that in a contract? So that's managing the expectations before, and of course, you, Mr. Supplier, never use it to make any other products for any other companies without our written authorization, right? So this is managing the expectations before. Then, if you're very hands-off, you just wait for the samples, that come out of the tooling after it's been made, and once the supplier believes that they are acceptable. And so you just wait. They design the tooling, they fabricate the tooling. So it's basically removing a lot of material from a big block of steel, typically. Then once they believe it's fine and it's going through the different processes that they use, they will do a first trial. Usually they call it T0 in some industries, and then there's usually adjustments to make, and maybe T1, T2. It gets to the point where they send you some samples and they say, well, this is the parts out of tooling, and then if you're very hands off, you just say, well, you look at it and either it's okay or not okay. It's simple approval, right? If you're very hands-on, you can go into a lot more things to reduce the risk, because some of these tools, are extremely expensive. It's a lot of money. If you invest in that for a lot of parts, it's relatively complex, very tight tolerances, very long series. Maybe it's got to take 1 million shots. It's not going to come cheap. So there's a lot of risk, because once tooling is made and you need to make some changes to it, after you've accepted it formally, you test it, and then you have some issues, and then you go back to fixing it. The fabrication shop is not going to do the changes for free, right? It's takes time and money. So and sometimes you need several iterations of that, right? And then if the tooling is made, let's say in China, and plastic injection, that process actually takes place in Vietnam or in India or some other place, well, but difficult communication, a lot of extra logistics to send the mold around, and extra time to get it to the fabrication shop and back to the injection molding shop. That you really want to get it approved. You want it to go through a pretty thorough validating process. So you go much more in depth in covering the risks. Okay, so managing the tooling is, you set your expectations, you watch, and you review what they're doing, if that makes sense, and then you double check and you confirm that's and then you might also want to keep your hands on that tooling at certain points, but we'll get to that. But yeah, in a nutshell, that's managing tooling. But again, it's quite different for different buyers.
Sure, but that's good, and it gives a quick overview of the fact that it's not just having your hands on the tooling, which you did refer to. It's a lot of different factors, such as the contract about who's owning IP, how to handle who's fabricating it, and all the rest of it. So that's great. Now, you mentioned if things went wrong and tooling needed to be changed, and it was already in, say, India and needed to be shipped back to China, and that's a risk that everybody wants to avoid. That's a mess, okay, and time consuming, expensive. That's just one of the risks we face, though, if we're fabricating and then using tooling. So there's probably quite a few to discuss. So perhaps you can go through a number of these risks that we need to be aware of, and maybe what's the solution to the risk.
Right. So if you look at the life cycle of a piece of tooling that is used for a manufacturing process, such as plastic injection molding, let's go through it one by one. First, somebody designs the parts, that will be made with the tooling later, but at least some, a design engineer, usually a mechanical design engineer, works on the look of the parts, and then into the details, and the geometry of the parts, what material, what finishing, and so on. Okay, so here, if it's not designed with the process in mind, it might actually be impossible to make, or it might be impossible to make consistently with good quality, or for low budget. Okay, so
Mm.
at this point, you need a DFM review, design for manufacturing review,
Right.
to review, to point to issues, and risks and so on, and get some iterations. Then let's say the part has been designed. There's the sourcing step, where you really need to communicate precisely to the suppliers, what you need. Um, what are the tolerances? What exactly is the kind of finishing? And then, when it comes to tooling, how many shots you need out of it, right? That is really, really important. And of course, before you share any of that, you need to have them sign a non-disclosure, non-use, non-circumvention agreement. And probably also a development agreement that will spell out what happens if there's a lot of quality issues, what happens if there's delays and things like that. What are the milestones, and maybe what are the payment terms like associated with the milestone. And later, hey, can you pull the tooling at any time? Yes, no, how is this going to happen? So you need to be specific and structured in your request for quotation. Then you need to compare apples to apples, of course. When you get the quotes, and then you need to screen out the suppliers. You need to see what their capabilities are. Are they going to make the tooling in-house or not? Do they know how to maintain the tooling nicely? How mature are their systems and processes, and so on and so forth. A lot of buyers we see, they pick the suppliers just because they have a nice polished English, or they respond fast, or they have a low price. Yeah, but low price in the end might come with much higher cost. So there's a lot of risks here, and you need basically to qualify potential supplier.
Yeah.
And again, if you're going to buy 1,000,000 parts, it's very different from 3,000 parts, right? So you can't always go very much in depth, obviously. Then somebody is going to design the mold. Okay. If you have not signed a development agreement, and if this is done by your supplier or the supplier of your suppliers, this is considered proprietary by the company that does that, and you will never see the design of the mold typically. So yeah,
it's an
you're
issue.
going to get the final version of that drawing, the 3D drawing of the mold, right? It's not, I would not say it's critical. Actually, I guess in most cases the buyer never sees that drawing, but it can be useful to troubleshoot, to understand things. And also when the tooling fabricator or the plastic supplier work on that, do they do their own DFM analysis, right? So the good ones will do maybe some simulations, on SolidWorks and these kinds of advanced software. You can do simulations, and if we inject it, is going to be the temperature is going to be different like this around the mold, and then it might lead to different types of issues. And then the draft angles, or okay, I don't want to get into any of the technicalities here, but you might need to change some of the angles relative to the mold itself for easy ejection. You might need to add some ribs to make some parts of the part themselves stronger. There's a lot of little things that a good supplier will suggest. Sometimes they even take screenshots of these of the CAD drawings and of the simulations, put it in a PPT document, send it to the buyer with some comments. I mean, that's great. You're working with a nice and professional supplier in that case, or at least they're really trying to go above and beyond. It is not something that small buyers can expect, right? Because they're not going to work with the first rate mold suppliers that are very, very experienced in that and working with large companies and so on and so forth.
Yeah.
Right? But that's always nice. So where was I? Yeah, the mold itself, let's say, is designed. Okay. Then it's going to be fabricated. And that takes, 20, 25, 30 days, because machining very hard steel does take time, and it's not just one process. You have various types of sort of cutting processes, if you want, EDM cutting and so on. At certain points, some of them are quite advanced and quite. It really goes into the precision of the location of the different cavities inside the mold, right? So that takes time, and well, what happens is obviously if you do that and they have more projects that they can handle, well, some of these projects are going to be late. For a tooling fabrication shop, this is production. Just like any other kinds of productions, things can get behind schedule, right? So in some cases, we just pay a visit and then we say, okay, what's sort of draw a Gantt chart and okay, how much time to do this, how much time to do this, how much time to do this, and then you're gonna do what? You're gonna do the trial, and then how long to adjust, and the next trial, how long to adjust, typically, and then either a visit on site to push them a bit, and to also see where it's made, and or simply push with phone calls and WeChat calls and things like that. So the risk here is the delay, right? And very often tooling is right there. Tooling fabrication is right there on the critical path. When you're developing your new product, you have your project, you really need to make sure that the full design, product design is frozen. You get, final prototypes that look like what you want, work as you like, and so on. And then you go into tooling. Otherwise, you try to do things in parallel, and what happens is that tooling is engaged, or is ongoing, or maybe already finished, and you're still making iterations on the prototypes. And guess what? You're always going to have adjustments to make. And adjustments on the tooling already made can be expensive, but also when they cut, they're always metal safe, meaning that they, it's pretty bad to cut too deep, and then after that, having to weld some extra metal, because then that part that is welded, just added up after the fact because they cut too deep, will not last a long time. So and it will sort of get worn out faster. So you will need to send a tool back to the shop to for maintenance, but actually it's relatively advanced kind of maintenance of welding again and polishing and so on. So
sounds expensive.
Yes, it takes a bit of time. It's expensive, and you need to do it regularly. Otherwise, you start to have quality issues and so on. So there's that, tooling. Yes, usually you wait and then you do the tooling once it's completely confirmed, and you don't. You don't want to make the tooling and then make changes to it, basically. And because also one thing you want to do before going into tooling is you want to make sure, okay, this really, the prototype I'm approving now, once tooling is made, and then we make some new tooling samples, pre-production, it's really going to look the same and feel the same and work the same and have the same physical properties and things like that, right? So that's something really, really important. Okay. Then once the tooling has been fabricated, they do their own little trial, then they do some adjustments. By the way, there's always a need for adjustments. Then, there's like a cycle. It's not a few hours, kind of more like 5 days a week to get to the next trial. So it's important that the issues are noticed, detected and pointed out. Otherwise, they fix not all of the issues, only some of them, and then the next trial, again, there's going to be still some issues, and so on and so on. And then different trials will show different issues. Sometimes they go in a certain direction, but too far, or something is not a problem, and then it becomes a problem. So there's cases where you get to trial 2, trial 3, and there starts to be a lot of tension because again, timing is critical often, right? So how to make sure that all the issues are detected? Well, then the idea is to send an inspector there, or to get them to send you the parts as fast as possible, and to get the formal approval or a number of issues. And sometimes maybe some parts are internal parts. The aesthetics don't matter. There's something that doesn't look so good. Actually, maybe the customer really doesn't care about it at all, right? But maybe dimensions are extremely critical. So this has to be made very clear. Okay, so now let's say you get the parts approved. It's okay. The tooling does its job, at least it makes the right parts. Typically, the tooling fabrication shop, finishes their job here, and then it's transferred. The molds are transferred to the factory that will use the molds for production. And there's sort of a sign off. It's important that they work together, right? So if you try to micromanage your supply chain, you pick the company that will make the tooling, and then you pick another company that will do the injection molding. There's a lot of conflicts here because the supplier of plastic will say, are your tools really good? Okay. But then as soon as there's a problem, they will say, well, because of your tools, your tooling is not good. Yeah, your tooling, we have to do some manual adjustment after that. And then, your tooling is, it's slower. We have to, the cycle time is not 40 seconds or whatever. It's, it's 1.2 or 1.5 minutes. That changes the economics a lot. Oh, really? Yeah, it's because of your tooling. So usually it's better to work very closely with the plastic supplier. And in some cases, they make it themselves, right? Or they manage it themselves very closely, and then they just send it to a workshop around them to do some of the very specialized processing. But in any case, they should be responsible for it. Otherwise, you never get out of this kind of problem. Now, there are special cases where it's not possible. It's going to be made in Europe or in Vietnam or somewhere far away, and making the tooling in China is sort of the only economic option, right? Because you have relatively good competences, and the cost is sort of unbeatable, basically, right? So in that case, before transferring over, you might want to do more than just checking the parts, right? So there comes the more in-depth validation of the tooling, and that can take a few different forms. Most basic form is to have an engineer go there and run through a checklist, right? look at the mold, anything that looks a bit weird, um, you know, and there's how to say, they try to estimate the adequacy of the different details of the mold. Okay.
Mm-hmm.
If there are spare parts or inserts, are they here? Are they present? Do the rings and the screws and things like that? Is the size adequate? You just go through a checklist like this, right? Cooling circuit in and out, is it clear? How is it going to be ejected? There's a lot of things, right? So you have an engineer who knows tooling who that checks it, that checks the mold. All right, that's one thing, and you probably don't want to skip that because a lot of weird things can be noticed at this stage. Then, if you really want to reduce the risk, what some buyers do is they actually force the tooling supplier, if they have some presses, to make a production run as a pilot run. We had an episode before on pilot runs. It applies for the first time a new product is going to be assembled, but also the first time is going, the components, the custom components are going to be fabricated. Well, right here, there's a new mold for a new kind of part, and you can actually do a pilot run, and the pilot run might take 4 or 5 days. It might consist of doing a full shift, then again another full shift, then following a certain procedure for maintenance, preventive maintenance. So taking the mold out, cleaning it and doing a certain number of things, then putting it back in, and then going again. And then at the same time, what happens is that you have someone on site who checks the cycle time, who checks quality, and how many shots do they have to do until they get to acceptable quality, right? Because this is also important. So all these kind of things to basically validate that it's okay, and it's really as expected, and you won't run into a situation where they put it in the factory in Vietnam and just time pressure and all kinds of pressure, and then the Vietnam supplier says, oh, problems because of tooling. And then you say, what's wrong with tooling? Look, we did all this validation run and it was fine. What exactly is wrong? You have a different kind of conversation here, right?
Yeah. That's a good point. That's a good point.
If there are issues, you should already have noticed them, right? So that's really validation through a real pilot run, right? Then once you have documented the setup, you have approved the parts, ideally you have validated the fact that it can run at rate, with the specified cycle time and so on and so forth. If you really want to go into the details, you do all that, and you transfer to the again injection molding factory that will sign off. Okay. What happens is that this plastic injection molding factory will do a first production, right? I mean, you haven't done the tooling for nothing. You want to go into production. So are they going to follow the same settings, or is, for example, the humidity and the temperature quite different? Also, the altitude has an impact. I mean, you need to think of all that. And they start running, so hopefully you have checked their systems and processes in advance. But if you want to have a close eye on them. This is a good time to have someone on site to see again how many parts do they need to go through to get to acceptable parts. What do they do with them? Do they regrind it directly and put it back? Do they use some virgin material, virgin polymer, or what kind of secret sauce are they preparing? Okay, you might not see all that obviously if you're on site. If they haven't done it in front of you, it's not always so easy. What are the issues basically? Checking up, does everything come out nicely? Okay, so and basic quality inspection, right? Just checking the parts, maybe doing some tests, confirming the physical properties, for example, and yeah, that is relatively standard. Then let's say the tooling, that production run has finished. What do you do with the tooling? You just leave it in the factory that makes the plastic parts. Maybe there's 2 months, between two production runs. Do you keep it there? So it's obviously very tempting for them to show your product to some other customers, and maybe to use your tooling to make some other products, your product, basically to sell your product to other customers. Plus, if they do that, obviously it has an impact on the lifetime of your mold, right? Maybe it's really going to do 500,000 shots, but these 500,000 shots are, you will only enjoy 200,000 because they did 300,000 for other customers, right? So that's a temptation. And some, again, if you're very hands off, that's fine. You have to trust your supplier, and in some cases that makes a lot of sense. In other cases, you just pull the tooling out of the factory, and you have it. You have a company like ours. Get it there, inspect it quickly, put it in storage, on pallets and in good conditions, and then when it's time to do another production run, deliver it again to the factory, and it removes that kind of temptation, and you have that sort of second pair of eyes on, does the mold need some maintenance? Can we see some signs that it's getting a little bit too fast into end of life? What are the issues that are starting to appear, right? Then also another benefit of that is that if you decide to switch from this supplier to that supplier, if you just let them have the molds, the day you pull the molds out, they know it's the end of the relationship. And in China, what does that mean? That can lead to a lot of bad blood. The entire relationship is going to be in trouble. They might hold the tooling hostage, or they might hold some of your products hostage, or who knows what. That's actually extremely common. So if you just get them into the habit of having the tools removed, well, just remove the tools and there's nothing special. And then you can send the tools to the other supplier, and supplier A will not really know what's going on, right? So that's another benefit. Otherwise, they might resist. They might keep it hostage. They might say, no, actually the mold is ours, or maybe they will say, okay, the mold itself is yours. However, we did the design of the mold ourselves, and we did not charge you for that. So that intellectual property is ours. We spent a lot of time on that, and pay us $20,000. And actually, that is a very sophisticated argument, because if your agreement with them does not cover that, it is actually a valid claim. right? So some
Interesting.
suppliers actually use these kinds of arguments when they
Mm.
are when they have some experience with it, right?
And perhaps if you go down to the factory yourself in the times that we're able to travel into China or wherever, that could be an issue as well.
Oh, if you have not paid them in full, or if there is some kind of conflict, they might sue you, and then you might
Mm.
get in trouble. Actually, if you're sued when you're in China, you might have trouble actually leaving China.
Yeah.
That sounds pretty bad, doesn't it?
Mm.
So that, yeah, you you know, talk to a lawyer if it gets really ugly. Uh, you know, don't make the wrong moves. But we're not
Mm.
lawyers, so we can't really advise on that.
Sure.
But then you switch to another supplier, where that other supplier is also going to have to sign off, and again, they're going to have the excuse of, yeah, your molds are not great. Yeah, that's why there's a few issues, and that's why it's, we have to raise the price because actually there are some other problems, blah blah blah. Right? So this always comes by, again and again, and that's why if you have them do again a pilot run and you have someone on site and you confirm, okay, this is the settings you used, um, this is uh, this is the cycle time that you were going through, this is the amount of reject you had, blah blah blah, confirm, then later they cannot really say, oh, it's much worse than expected. Hey, that day you made it run correctly. What's wrong now? You don't know what you're doing. It's not the problem of the mold. Okay, so it's a good way of keeping the risks down and just pushing it back to the supplier. And then again, if we look at the full life cycle, well, the end of the life cycle is end of life of the tool, and then you need to go again, make a new tool, and then over time, people, get a little bit smarter, have some new ideas to make it a little bit better. That happens, and again, the wool idea, right? And it might, if you are more confident about the volumes, maybe you make it with 2 cavities, 4 cavities, right? It's going to be more expensive, but production will be much faster. And with the same mold, you will make many more parts. So that's something to keep in mind. So if you look at it sort of A to Z wool life cycle, these are the typical steps and how buyers can get involved in managing the tooling.
Yeah, it's almost can be split into four sort of steps, can't it? So you've got the design of the tooling, the fabrication, then the management of risks that happen whilst the tooling is in use, and then what happens when you're between productions or you're moving to a new manufacturer or yeah, so
Mhm.
it's quite interesting to see it in that scope. And actually, when you start talking about tooling at the start of the podcast, it's like, well, okay, tooling, yeah, we get that, it's important, but there's so much to be concerned about if you're an importer using tooling.
Correct. And actually, we already discussed some of these points just a few months ago in another podcast episode with Andy Bartlett,
Yes.
an industrial designer in the UK. But it just comes back so often. There's so much money and risk and impact on timing and so on. If you develop your own electromechanical products, this is very often something that you need to work on. Yeah.
Yeah, well, Andy definitely covered it from the perspective of product designer as well, which is good. So together, I think these episodes are very helpful, and I will include the link to Andy's podcast, of course, that you've mentioned too. To move on a little bit to the contract side of things, at the start of the podcast, we said we were going to talk about what needs to be in the contract. You've also mentioned it in passing just now. So, what do we include in a tooling
Well,
development and fabrication contract in order to help really lock down our IP and our access to the tooling as and when we want it?
yeah, well, there's not that many points.
Okay.
And here I'm assuming that the buyer is okay to pay for the full cost of the tooling and wants to own the tooling and wants the control that comes with it. Because usually when there's a contract involved, that's the case.
Yeah.
Well, the contract says, who owns the IP rights, all of the IP rights, let's say, involved with the tooling and its design. It's got to clarify the obligations of the supplier to keep it in good working condition. It should mention, the sort of the commitments of how many shots it should endure over the lifetime, and based on using such or such polymer. If it's ABS, not going to be the same as PVC or HDPE and so on, right? So try to document all of this. And what happens if you want to move on to another supplier? Can you pull the tooling? So the contract usually will say that, if the buyer follows that kind of process to request the tooling, then tooling has to be made available within X days, and the buyer can come and pick it up. And if there are issues on the tooling, then the supplier will be responsible actually for fixing it within X days. I mean, it doesn't go much deeper than that. But if you do not have that, you might invest a lot of money in tooling and actually just giving it away to your supplier and then be hooked by your supplier and never be really able to walk away.
Yeah, and we have discussed, some of the pros and cons of working with the different types of suppliers, and the same applies when it comes to, whoever's using the tooling. So if you're working with, say, a contract manufacturer and you've bought your own tooling, you're going to have a lot more security and freedom probably than if you're working with, let's say, an OEM or an ODM who has had maybe a big hand in developing and producing the tooling for you.
You're absolutely correct. I don't have much to add to that.
Yeah, so I'll also add the link back to the older episode of the podcast where we talked about the different suppliers and sort of the pros and cons of working with them. And it really is, a lot of it's about control, isn't it? So that's good. One thing we haven't gone into yet is the method of moving tooling between suppliers.
Well, we have a page about that, so let's link to it. Basically, how many, these are the steps you need to follow, and who does what. What does the buyer do? What does the supplier do? And where does maybe an inspection company fit in to confirm some of the steps?
Yeah, that's a good one to read. So I'll include that one too. Great. Excellent info today. Using tooling is probably not uncommon for a lot of people that are manufacturing, as you said, electromechanical products around Asia. So good topic today.
Yeah, thanks. Thanks, Adrian. And,
great. Thanks, Renaud. And thanks, everyone, for listening.
All right. Yeah.
Thanks for joining us. If you've enjoyed today's podcast, don't forget to like and share, and you can subscribe on Apple Podcasts, Spotify, and all other places that you get your podcasts from. See you next time.